Today's video is going to talk about exponential growth and decay. Exponential growth occurs when a quantity exponentially increases over time. So there's a formula for this, and it is f of t equals a times 1 plus r to the t power. And A represents the initial amount. So this is the amount of something that you started with, and it is going to exponentially grow. R represents that growth rate. And T represents time periods. So if it grows by 7% per month, this would be how many months. If it grows per year, it'd be how many years, etc. So the way I want you to start with each problem is to write down those three variables we just talked about. We want to know what A equals, what R equals, and what T equals. And we also want to know, is this growth or decay? And on this worksheet, they happen to be separated into categories. This one is growth. And we're also going to see that because it says the value is increased. So let's read through the problem. The original value of an investment is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. So the initial amount, the A value, is going to be $1,800. The rate of increase, or the growth rate, is 7%, but we are always going to divide that by 100 to get 0.07. You have to convert this from a percent to a decimal before you can use it. And then T is the number of time periods. It says it increases by 7% each year, and it wants to know after 15 years. So the only kind of time period that we're using here are years, and that's what we're going to put there to remind ourselves that this is by year. All right, so it wants us to write an exponential function, and all we're going to do is plug in these values into our formula. So f of t, and that is always going to be the beginning. That's like saying the amount right now is this. F of t equals the A value, so 1,800, times 1 plus r, which is 0.07, to the t power. And when you're writing the formula, you're going to leave t and f of t in there. But then it asks about after 15 years, how much there will be. So that is going to be f of 15. And that just means that we plug 15 in for t. And when we type this in our calculator, we're going to get 1,800 times 1.07 to the 15th. And you can type that straight in, and you're going to get $4,966.26. Now we're going to talk about exponential decay, and this is when a quantity exponentially decreases over time. And the formula for this is f of t equals a times 1 minus r to the t power. So this is the only thing that changes between the two formulas. For growth, you have a plus sign, which makes sense because there's more of it. And for decay, you have a minus sign, which makes sense because there's less of it over time. And then the variables represent the same things. So A is the initial amount. And instead of growth rate, this will be the rate of decay. And T is the time periods, the number of time periods that pass. And our example here says an investment of $1,200, so that seems important, is losing value. That means decay at a rate of 4% each year. Write an exponential function to model the situation, then find the value of the investment after 9 years. So there's all the important information. We are going to start our problem by writing out the variables. And then we know that this is decay because it is losing value. And the initial value is $12,000. The rate of decay is 4%. And when we divide that by 100, we're going to get 0.04. And time is in years. The only time frame used in this problem is years. So our function will be f of t equals 12,000 times 1 minus 0.04 to the t power. And remember, whenever we're just writing the function, we leave t and f of t in the equation. Now it wants us to find it after 9 years. So f of 9 is equal to 12,000 times 1 minus 0.04 to the 9th power. So this will be 12,000 to the 0.96 to the 9th power. We can type that in our calculators, and we are going to find that the value of the investment after 9 years is $8,310.41. Thank you guys for watching, and have a great day.